Okay. So I had to stop there because I could only do 15 minutes on that last one. I'm going to try something new this time so that I don't have to so that I don't have to stop it after 15 minutes. Hopefully, just realize that the door over there is open. It's bothering me. Hang on. Um, all right. So anyway, where was I? Okay, so where I was that this electrical current, goes all the way around. And this is what I was saying. You get one from one place on a wire to another place on a wire. This is exactly how it goes. It goes from here all the way around through atoms and atoms and atoms and atoms. This not one electron, but one electron jumps to here, and a different one to here, and then a new one to here, and then a new one to here. And a wire is only made out of metal, and that metal has atoms all the way down the wire. There's atoms, and so when an electron jumps from one atom to the next atom, and then the next, and then the next, the next, next, that's an electrical current that goes down the wire and from the outlet all the way to a lamp or something like that. And that's how electrical energy passes from one place to another. That's how it transmits from one place to another. It's through these bouncing atoms from sorry, not bouncing atoms, bouncing electrons from one atom to the next. Okay? And that is electrical energy and how it is made. Move this down here. Okay. Next page. Come on. I went too far. Okay. Hello? What's going on now? Anyway, all right. So the next thing here is kinetic energy, which is energy of movement. All things that move have kinetic energy, no matter what. This is going really slow. I wonder why. Moving cars have energy. Everybody knows that a moving car has energy. Okay, there I am. A moving car has energy, a lot of energy. If you've ever been hit by a moving car, you know that it has energy. And the faster it moves, the more energy it's able to hit you with. And if it's moving fast enough, it's going to hit you with enough kinetic energy to really do damage to your body. I mean, if it wasn't moving fast, it wouldn't have a lot of kinetic energy. So it wouldn't have a lot of energy to really hurt you. No one is afraid of the car that comes at them at 1 mile an hour. Oh no, I'm going to get squished. Well, probably not, because it just doesn't have enough kinetic energy. It's got a big mass, and so if it does nudge you, yeah, you're going to move. But it's not going to really blast into you the way a car that's going 50 miles an hour or 100 miles an hour would blast into you. So the faster it goes, the more kinetic energy something has. It's a type of energy that has to do with movement. And we know that objects have kinetic energy the faster they move, because imagine if they hit you. Okay? The faster it goes, the harder it's going to hit you, the more energy you're going to feel it have. And that's because the more energy it does have, the more kinetic energy it does have. Kinetic energy, very important thing when we get to 2-2, and especially 2-3. Falling rocks have kinetic energy too. Anyone who's ever gotten hit by a falling rock coming from overhead, and if you only take, let's say, a rock, let's imagine that this phone, okay, is a rock, right? I'm not all that concerned about this rock coming down and hitting my head. It's just, it doesn't hurt that much because it's not going that fast. When I let it go, it doesn't really get that much speed going before it hits my, head. So it doesn't have a lot of kinetic energy. It doesn't have a lot of energy of movement to it. And let me make myself big just because it's fun. Or not. Or so. But if I was to drop it from way up here, it would get a lot of kinetic energy before it hits my head, and then it's going to give my head a lot of that kinetic energy. So much energy that it's going to hurt me. And so I'm not going to drop it from up there, because I don't feel like doing that. I don't feel like hurting myself. When I come back to school, I'll consider it. So that's kinetic energy, energy of movement. Next, potential energy. Potential energy is energy that can be turned into other energies. We've actually already talked about a few of these. We talked about nuclear energy. That nuclear energy is stored energy. It's stored in the nucleus. It's just waiting to be used. And when you shoot that little neutron into it and it explodes and it lets out that energy, it goes from being potential energy to something real. Chemical energy is the same way. You store the energy in the bonds between two atoms. And when you break those bonds, you release the chemical energy. And you make it, you release that stored energy, and now it becomes something that can be used. So all that is potential. It's not being used yet. It just has potential. Like a lot of you. A lot of you have potential. You haven't used it yet, right? It's in you. You just have to make it happen. So this is kind of like potential energy. So there's chemical potential energy, nuclear potential energy. There's a couple more that I want you to know about, and over here is where you can see one. See this lady here? This lady here is this is my wife, and my wife enjoys going for hikes and rock climbing and things like that. It's kind of a small picture of my wife, but imagine it's my wife. So she's right here. Now my wife, what she really likes to do is she's right here. And what she really likes to do is likes to rock climb and wait until somebody comes by. Let's say it's like a person right about here. And what she does is she waits until they walk by this way. And when they're right underneath, she decides that she's going to jump. She jumps and she lands on them. And she squishes them. And they die. This is what she likes to do. Now notice, my wife is smart enough to realize that the higher she gets up off the ground, the more likely she is that she's going to really do damage to somebody. Kill them, maim them, well, let's keep it simple, kill them. So she gets up high off the ground so that when she jumps, she has lots of kinetic energy when she lands, so that bang, it's over. She does not ever decide to try to squish somebody by standing right here. And that makes no sense. You can't squish somebody here. You don't have the potential to squish them. And that's what I'm getting at. What I'm getting at is something called gravitational. Why is it so slow? Gravitational potential energy. Okay? Oh, this will not do. Let me see something. I don't know why it's going so slow. All right, so this is gravitational potential energy. It's energy that's associated with the height of something. So I'm just going to put, the more height you have, come on. Oh, gosh. The more height you have, the more gravitational potential you have. It's the potential to do something. That's not what I want to do. It's the potential to do something. She has the potential to squish someone if she jumps. If she's on the ground, no potential. So the higher she goes, the more gravitational potential she has. Oh, it's really having trouble here. Okay, so that's one type of potential energy to go along with things like, the chemical potential and the nuclear potential and everything like that. you've got now gravitational potential. And this makes sense. The higher something is, the more potential it has to do damage. Just like that phone over my head. This, less gravitational potential. This, more gravitational potential. No gravity, no potential. If there's no gravity, if we lived on a gravity-less planet, my wife would never be able to kill anybody by coming up on top of a rock and jumping off. Because if she jumped off, she would just go, ah, and she would just, float away. And she would never squish anybody. So you need, if you're going to be high up off the ground and expect to really hurt somebody, you need gravity. And the higher you are up off the ground, the more gravity will help you get faster and faster so that when you do hit, bang, you do some damage. So this is potential energy. It's not being used yet, not until she jumps. It's just potential. Another type of potential energy is elastic potential energy. I don't have an elastic here, but when I come back to school, I will make sure that I have an elastic band, a rubber band. All you have to do is stretch it. Now, if I took a rubber band, right, and I pulled it back just a tiny bit and aimed it at your eyeball, you wouldn't be very scared, because I haven't pulled it back very far. But if I took it and I pulled it way back and aimed it at your eye, and then let go, then you'd be scared. Or even if I didn't let go, you'd probably be scared. That's because as I stretched it, the more I stretched, the more I had the potential to do damage. Because if I was to let go, all that potential would turn into kinetic energy and hit you. Only a little potential, only a little kinetic. Wouldn't hurt you much at all. But a lot of potential turns into a lot of kinetic. So, in summary, this person has the potential to put out an eye. If the rubber band is not stretched, there's no potential. This is called elastic potential energy. It's the potential energy of something that can be stretched. Anything that can be stretched can get elastic potential energy. A spring, if you let it go, it goes pong, If you only pull it a little bit, you're only giving it a little potential to go prong. You pull it a lot. Oh, a car, one of those cars that you pull back and it clicks. Click, 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 click. And then you let it go. And it zips down on the floor. Those little cars that you have that you pull back, every time you pull it back, you're winding a spring in there. So you pull back and you're giving it elastic potential energy. It's only potential until you let it go. And then it uses the potential to go. See where we're at. Okay. Very good. Let's see. What's next? I don't think there's too many things left. Sound energy. Come on. Okay, all right. Sound energy. All I really want you to know about sound energy is that it's mechanical energy that goes through something. That something's called a medium. You don't have to know the word medium. I just want you to know that sound is actually mechanical. It's actually moving. Anybody who's ever been in front of a big speaker can actually feel the sound. Yeah, you're feeling the sound. What you're feeling is vibrations that start at the speaker and they come at your face and they hit you in the face or the body, and you can actually feel that sound. Well, that's what your eardrums do all the time. Your eardrums feel sound. These little tiny pulsations of air. You make a sound and it sends out little little pulses of air. And the pulses of air, this mechanical sound energy, goes into your ears, hits your eardrum, and your eardrum sends a message to your brain and you hear something. But that that sound energy has to go through something, the air. Your air needs molecules. And when that sound energy goes and it hits a molecule, that molecule will then hit the next molecule and hit the next molecule and the next molecule and the next molecule. And that wave of energy will travel from molecule to molecule to your ear. And then that final molecule will hit your ear drum, and then you hear something, which is kind of cool. Don't worry so much about sound. And that is, I believe, section 2.1. We're going to move on to section 2.2. Section 2.2 says, identify different forms of energy transformations. The fact is that everything undergoes some form of energy transformation. I mean, that's what the universe is made out of, is turning one energy into another energy. You don't just always have just one energy. Oftentimes you can take that energy and turn it into some other type of energy. We just went over about 7 or 8 types of energy. You had sound and light, you had heat and potential, kinetic and electrical and nuclear. Okay, there's all of them. But they can all turn from one of them into another one of them. So let's look at some examples of energy transformations. You always start with one energy and you turn it into another type of energy. So let's look at some examples. Highlighter. Television. In a television, electrical energy, electricity, turns into light and sound. It's happening right now while you watch me. There's this, you're seeing me up on the board, hopefully. You're seeing me up on the board, and how is that happening? It's because the LCD projector is getting electricity going into it. Well, that electricity going into it through the wire it's transformed into this light energy that comes out of the bulb and onto the screen. You can hear me, hopefully, because there's an electrical energy that goes from the wire to the speakers, and the speakers turn that electrical energy into sound energy. And usually in a television, you get light and sound together. The cord, goes from the outlet, the electricity goes into the TV, and what comes out. A lot of times energy transformations can be looked at like that. What goes into the TV, or what goes into the thing, and what comes out of the thing. Okay, so what goes into a TV? Well, electricity goes into the TV. What comes out? Light and sound. What happens in between? Well, that's where the TV turns the electricity into the light and sound. It transforms it from electricity to light and sound. And if I was to write that, oh boy, I would write it this way. And eventually I'll get that. Okay, so I would write electricity, arrow, light, and then I would also write electricity, arrow, sound. Notice that? And that's how you would write an energy transformation. You've got one thing, electricity, and then an arrow. The arrow means turns into, and then light, or electricity turns into sound. That's what the arrow means. It means transforms into something else. One type of energy turns into another type of energy. You can't have an energy transformation that's just one energy. It's not like a TV. What's the energy transformation in TV? Light. No, you got to turn from one thing into another. That's like, a caterpillar turns into a butterfly. You don't just always have butterfly. What's the metamorphosis? Butterfly. No, you need caterpillar to butterfly. Tadpole to frog. Electric to light. Transformation from one to another. Notice that I don't have electricity. This is something that I didn't write. Electricity, turns into light, which then turns into sound. This is wrong. The first part is correct. The electricity does turn into light, but the light energy does not turn into sound energy. The things that are flashing on the TV that you guys look at, those things that you're looking at on the TV, the light is not making the sound. There's another part of the electricity that goes into making the sound. The light doesn't make the sound. So don't write it like this. If there's two things being made, don't make one make the other unless it really happens that way. All right. Eating. Eating, we all do it, I think. And because of that, it's an important thing for you to understand. When you put food into your body, you're putting chemical energy into your body. That chemical energy of all the bonds in all the chemicals in the food, all that good stuff and the sugars and everything. Sugars are nothing more than carbon molecules, carbons connected to carbons. That sugar is chemical energy for you. And that chemical energy can be turned into all sorts of things. Very slow. Okay. So eating is chemical energy turning into all sorts of things. The chemical energy in food allows you to move. Moving is kinetic. You move because you ate. If you stopped eating, you would stop moving. Hope that makes sense. Why is this not very slow? I don't understand why. Your body makes heat. If you stopped eating, your body would stop making heat. We call this death. Yes, this is called death when you stop making heat energy or you stop moving. Your heart stops moving or something like that. You die if you stop having chemical energy turning into these things. Okay? There it goes. Heat energy. And finally, when you talk incessantly, like some of you do, you might be doing it right now. That's sound energy. You wouldn't be able to make sound energy if it wasn't for the fact that you ate something. If you stopped eating, you would stop making sound too. So your body is turning this chemical energy, transforming it into these other types of energies in your body. I'm just going to hit that like so. And eventually it'll happen. And once that happens, I'm going to stop recording. Or you can just turn me off and just make sure that you highlight sound energy. All right? Hopefully this all made sense. Hopefully this worked out. I think we've reached pretty much the end of the time that you probably have. You may have a few minutes left over. Just stay in your seats and do the right thing. Enjoy yourself and relax on a Thursday, for gosh sakes. And don't turn too much of that chemical energy into sound energy. Thank you. I'll see you tomorrow.